by far one of the most confusing looking pieces of tech I've ever held in my hands, but once I explain to you how they actually work, you are going to be blown away by how innovative and useful they are. So when I first take these out of the box, you'll quickly recognize that they're headphones, but the closer you look at them, you just realize that there's something weird about them. And then when you see them on somebody's head, you're gonna get even more confused. So these are from a Japanese audio company, and they're called the Noom One, and they're a very specific type of headphone called an open back headphone. Now, these open back style headphones have long been considered the best way to experience the highest quality audio when compared to their closed back counterparts, but they do have one major disadvantage. Sound can bleed out, and you can't really wear these things in public, so you pretty much have two big speakers on your head. But the Noom One solves this, and it's so cool how, let me explain. So they basically implemented noise canceling tech like you have on regular headphones, but they do it in reverse. So on regular headphones, they take the noise from the outside world and they play a reverse sound wave so it cancels out the noise going to your ears. But on the Noom, they use that same technology, but instead of the sound coming in, they take the sound going out and they play a noise canceling wave that'll cancel the sound going outward. And they play that canceling noise through these slots here that you see on the outside of the headphones. Like, even though the speakers are exposed and right there, you probably can't even hear that I'm playing music on full blast right now. I really love these things, not just for the cool noise canceling tech, but they're also insanely comfortable because they're totally open and there's so much air coming through your ear. I can wear these things all day when I'm working. The microphone on them is great. The battery life's incredible. They have their own companion app so you can like mess with the EQ. Thank you to Noom for sending me these things. I'm very impressed. I will put a link to them in my Amazon storefront in my bio if you want to check them out for yourself. I believe they're also going on sale for Black Friday. If you want a unique audio experience, you wear headphones all day, you want open back, these might be the winners. Thanks for watching. I'll catch you in the next video. Today I'm going to teach you how e-ink displays work in under a minute. E-ink displays can be found all over the place, but they're really common on e-readers. And they have a super unique characteristic where they require zero power to display anything on the screen. They only need the power to change the screen. Now, there's no power hooked up to this. It'll literally stay like this forever. Now, here's how they work. So they're actually very similar to an etch and sketch, where magnets move physical particles around on the screen. The display is basically a grid of tiny electromagnets, where each electromagnet equates to a pixel on the display. Now on the top of the display, there's a really thick white liquid that's like the consistency of jello. And then underneath that jello, there's a bunch of black magnetic particles. So picture this here as the side view of a single pixel. You have the black magnetic particle on the bottom and the white jelly at the top. The particle will stay there because the liquid's so thick. But if you turn the magnetic one way, it's going to push that particle up to the surface of the gel and make it look black. And if you flip the magnet the other way, it's going to pull that ball down and make the surface look white. And then by doing this with all the pixels at once, you're able to display things on the screen. Because the gel is so thick, the particles stay where they are, and that's how e-ink works. So I have a few hours of free time and an idea that I think is good, so let's invent something. So one of my creator friends, Tyler Stallman, made this post about how there's no elegant way to label hard drives. And as soon as I saw this, I immediately thought e-ink. E-ink is a type of display that's used really commonly on e-readers, and it's unique where it does not require any power at all to display something, only to change what's on the display. And I thought if you could embed an e-ink display into a hard drive and build a really easy way to change that display, that would solve the problem. So let's do just that. Here's all the parts I plan on using. First off, we have the e-ink display. This is just a raw display. We're gonna need to hook up a computer of some sort to send data to these pins to make it display things on the screen. And even though no power or anything is hooked up to the display, you'll see it's still displaying a clear image. Again, that's the key characteristic of e-ink we're going for in this project. And signals to the display for it to display stuff. We're going to use this ESP32 Microcontroller. It's basically a tiny little computer you can program to do anything you want. In this case, we're going to have it output data from these pins here and inject that data into the e-ink display. I chose this specifically because it can connect to Wi-Fi, which is a key feature we're going to use for this project. I'll show you how in a little bit. Then we have a hard drive where we're going to embed all of this onto. Step one, I need to figure out how to connect this screen to this chip and make sure I could actually make it work. So I've got the screen plugged into the ESP32 here, and I've written some test code that's just going to output a bunch of test data onto the screen to make sure it's plugged in properly. It's just uploading here, and hopefully it's doing something nice. Okay, we got the screen writing and updating text. Now that I have the test script going, I'm gonna figure out how to write my own code to display what I want on the screen. So I think I've got it all figured out here. The code was pretty simple. The screen should output, hey, it's Brett.tech. It's just gonna upload here. I'll fast forward while it does. Upload's just about to finish. Nice. Okay, we can now write our own text to the screen. Now let's try to make something that would be useful as a hard drive label. This is quite a bit more complicated to write, but I think I have something. It's just finishing uploading. And yeah, okay, this turned out really well. So the idea here is you have two blocks of text to describe what it is. You have secondary text, and you have a date that you can put in, as well as an icon. Now we just need to make this easy for the user to configure, and that's where the Wi-Fi and the ESP32 comes in. That Wi-Fi code was way more complex, but I do think I have this figured out. I might need to cut this to hide sensitive info, but I'm in my phone's Wi-Fi here. I don't need to download to set anything up. All I need to do is connect to e-ink SSD. So we're gonna select that. Now, as soon as I select that, all of these custom fields are going to show up. They could type text into. That's going to correspond to the different lines of text 1, 2, 3, 4, and then the icon here. Let me enter some of those and we'll see if this works. We've got that entered in. We're going to do this in real time. We got line 1, hi TikTok, tester 1, 2, 3, July 5th. We're just going to hit save and we're going to see if this works. I might again need to blank this out because of the Wi-Fi credentials and stuff. It's doing something. Oh my god, that actually works. So we have line 1, hi TikTok, tester 1, 2, 3, July 5th. We can configure that all from our phone without an app. Let's bundle this up. I'm gonna keep this simple. I just designed this enclosure that I'm gonna 3D print. It's gonna fit the SSD into it, as well as the screen and the ESP32. Gonna send that off to the printer now. Roughly an hour later, we are all done printing, and this looks incredible. I'm gonna have to solder some of these wires directly to clean them up a little bit. Let me just go do that real quick. Okay, not perfect by any means, but we're all soldered up and we're ready to put this into the case. Well, after quite a bit of fiddling, I think that looks pretty good. Let's test it out. Okay, let's test this thing out. We just finished a shoot, so we connect to the ESP for power temporarily. Then we connect to its Wi-Fi. All right, then we have our 5 configuration text boxes. Let's just say we just did a shoot snowboarding. I'll enter all the info there. Okay, so I have skiing, and then it's B-roll. It's not yet digested, so we know not to delete it, November 15th. And I have the icon as M. I uploaded an extra icon to specifically match this. Again, I might have to blank out the phone here to save my credentials. Let's just hope this works. It looks like it's refreshing. Look at that. Don't tell me that's not actually useful. Skiing, B-roll, not yet digested. It's that easy. And most importantly, when we pull that plug, that data persists on the drive. All right, cutting the video there because I think this is going a little bit long, but for a first proof of concept of an idea, I think this came together incredibly well. There's some obvious things to fix, like finding a different source of power in the hard drive instead of having to power the ESP independently to flash it, cleaning up the top here a little bit, but I think as this is a pretty usable little setup. Love to hear your guys' thoughts and suggestions in the comments. Is this a good idea? Should I keep working on it? Thank you for watching, and I'll catch you in the next video.